and welcome to the 18th annual Rouge River Water Festival and our first virtual water festival. We began this festival back in 2003 to help educate elementary students about our most precious resource, water. This project is, and this festival is a collaboration between Cranbrook Institute of Science and the Oakland County Water Resources Commissioner's Office. And thanks to our other partner, Pure Oakland Water, who provides the funding, we're able to offer this program year after year to Oakland County teachers and their students. Because it was virtual this year, we decided to open it up a little bit. So we have some of you watching us on Facebook Live. We have teachers and students and folks at home joining us on Zoom as well. So again, thank you so much for joining us. My name is Michelle Arquette Palermo. I'm the head of the Freshwater Forum, and I have been involved with the Rouge River Water Festival since day one. If you joined us yesterday, you learned about where water is. Today, I want to talk about how water shapes our land. Because it's such an integral part of where we live here in the state of Michigan, we thought it was really important for you to understand where those Great Lakes and our rivers came from. And you often hear that the glaciers, when they retreated about 14,000 years ago, left us the legacy of these Great Lakes. But the story goes actually much farther back than that. So before I get started on that origin, I want you to understand a little bit about how water moves. So to do that, I created a little model here. And inside this bin, you can see underneath it, actually I'll pull it out so you can see it, is a piece of foam. A lot of times kids say, is that a brain? Is that macaroni and cheese? No, it's just the spray foam that we put on a piece of foil and let dry. Because what we want to do is we want to use this as a landform. But our land isn't flat, so we don't want to just put it in this plain bin. We need to give some structure and some shape to that land. So I got this in here, and then I have a piece of foil to contain my mess, so my foam doesn't get too messy. And you can see the foil, right? It's all crinkly, and it's got some hills and some valleys. And then I put some paprika on here only to make it easier for you folks to see on your cameras. Because clear water on foil doesn't video very well. So I added some paprika that really make it stand out. And it also looks like soil or dirt, sediment, right? So we have the surface of the earth with hills and valleys and lakes, rivers, and streams. And it rains. When it rains, that water hits the surface and it moves. Because the earth isn't flat, it moves in one direction and one direction only. A lot of times people will say, yeah, it always moves south. Sometimes it moves north, sometimes it moves east, sometimes it also moves west. And as you can see, as I'm holding this up, all that water is running off into the bottom of my container. So the more water I add, the more of my soil moves. And where does it all collect? In the bottom, because gravity is working and it's all settling in the bottom. And because I have a hard plastic container, it's collecting. Well, guess what? The bottom of the Great Lakes is like my plastic container. It holds that water in. But each of our Great Lakes, and I'll show you one more, just get a little bit. You can see like different waters moving in different directions, but it's all ending up in the bottom of this container. Move that out of the way. So when I talk about the Great Lakes, where exactly am I talking about? Here's my favorite map of the Great Lakes. And you might not be able to see the words and the details, but you can see the different colors. So the blue up here on the top is the area or the basin that drains into Lake Superior. It's the northernmost of our Great Lakes. Then you see the orange and the red over here. That's the drainage area for Lake Michigan. Then the green is Lake Huron, so all that land that drains into Lake Huron. Then we have the other blue, right? That's Lake Erie. And then we have the light orange and the light yellow, which is Lake Ontario. So all 5 of these Great Lakes are a little bit different. And when we're talking about the geologic history that gave the land the shape before, long before the glaciers filled those waters, they were formed a little differently. So I want to start with Lake Superior. So Lake Superior here was formed, oops, move this out of the way, this way. 1.1 billion years ago. And what happened is our continent experienced what we call a rift, right? So the land was trying, thanks to plate tectonics, right? That land was trying to tear apart. It was ultimately unsuccessful, but it still created a rift, what we call the Mid-Atlantic Rift. And if you look at this map, it actually starts in Oklahoma and then sweeps up through Canada and down through Michigan. And it created this rift. And if you look up here, there's this big pile of blue in the middle of that rift. That's Lake Superior. So in order to demonstrate that, what you have, I'm going to use a Snickers, right? So we have 2 lands, like we have this continent, right? And then it started to split apart. And on the top, you have trunks, see them falling to the ground. But in the middle, right, you have pieces that are sticking together. And so it was unsuccessful. It stretched, the land stretched, and actually created a rift or a valley. And then over the period of many, many years, so if you have this valley, right, and then it fills up over time with sediment, right? So rocks and sand, that's what's in this container, right? So over time, that filled up. But it wasn't Lake Superior at that point. It wasn't until the glaciers filled it up, the retreating glaciers filled it up many, many, many years later that Lake Superior was formed. But what it did is that rift created the foundation that later became Lake Superior. So it was formed very differently. If you go to Lake Superior, you can actually see the volcanic rocks, the basalt, the big cliffs and craters off to the side. There's a place in Marquette called Black Rocks. You can see those. You can go up into the Keweenaw Peninsula. You can see evidence of these old rocks that are exposed that were created 1.1 billion years ago. Now, the rest of the Great Lakes, what I like to call the lower Great Lakes, or the basin, people call them the basin lakes as well. Sorry, let me get that in there. So the orange, the green, the other blue, and the yellow. That basin was formed differently. About 300 to 500 million years ago, that land area was actually covered in what we call an ancient inland sea. So what we do know about water, right, and lakes is they're not just a cavern down to the bottom of the floor, right? We actually have sand and gravel and rocks at the bottom of our lakes. Well, over long periods of time, you get more deposits of rocks and gravel. You also get sand, okay? These ancient lakes or inland seas, sorry, grew and then shrank and grew and shrank, grew and shrank over a period of about 200 million years. But they were filling up at the same time. Okay, you can see the sediment in the bottom of that. Now I'm going to switch. So think about that area in the lower Great Lakes as a bowl. Okay, so you have your land mass, right? But you have water, and the weight of that water causing that pressure, right? And pushing in over time. And that bowl gets bigger and then it shrinks. It gets bigger and it shrinks. Well, you get the land on the side, or the sediment getting pushed up on the sides of the bowl. Then it shrinks. You get another bowl. You have some more pressure. You get more pressure from water dropping on there. Okay? Shrinks even more. What happened is, and over the course of that 200 million years, we had 30 stacked bowls. So think about Michigan and that lower Great Lakes Basin as 30 stacked bowls as those inland seas shrunk or got bigger and then shrunk, got bigger and then shrunk, and created this stacked bowl system about 30 times. And the oldest rocks, right, and the hardest ones to actually erode are the ones that are up on that edge. So if you ever go to Wisconsin, there's a place called Door County. You can actually see them in parts of Canada on the other side of Lake Huron. So there are areas where you can see the edge of the bowl still exposed. But the weight of the water over time really pushed down that center and created a bowl. Well, what happens if I pour water on a bowl versus water on a plate? The bowl is going to fill up and the plate's going to fill up a little bit, but then it's going to start to spill over onto the sides. So because of this geological phenomenon that occurred 300 to 500 million years ago, our land was shaped by water. Lake Superior was shaped by a rip, right? Or the space that eventually became Lake Superior by that rip or that rift in the land. But this was actually shaped by water that was getting bigger, or seas getting bigger and shrinking. Okay, hold on, I got a flour, sand, and Snickers all on the hand mix for things a little sticky. So that's how those two regions were geographically or geologically formed. Okay, so now fast forward 100 million years to 200 million years ago, and we had the Laurentide ice sheet coming down. We were in the Laurentide ice age. So that covered the surface, right, with a layer of ice. It was 3,000 to, I'm trying to remember, at the thinnest, it was 3,000 feet, right? So that's, or 1,000 meters. I have a little tiny glacier that I made. So you have this big chunk of ice sitting on top, right? So it's all sitting on top of there, and as it's coming back, gotta come up a little bit higher. There we go. Right? It's dragging sand and gravel with it, but look what it leaves at the bottom. Liquid, right? So as those glaciers were carving out the sediments that had filled up, right, from that 30 stack bowls, or in the case of Lake Superior, that rift that had filled up with sediment for about 1 billion years, right? So as this is coming backward and it's melting, it's leaving water in the lowest spot on the land. And so we know, right, that water only moves in one direction, it moves downward. It's going to find that lowest spot. So while the glaciers was critical in the formation of our Great Lakes, it was really that geologic history that started a little over 1 billion years ago that really gave us this great resource that we call the Great Lakes. So one of the things I hope you understand from what I've shown you today is that the Great Lakes truly are unique. It's our history and natural history that formed the shape of the land. And then as those glaciers retreated, they left us our precious Great Lakes. So each of the lakes are very different. And one of the reasons why Lake Superior is so deep as compared to the others is because that was formed by that rift, that mid-continent rift, and when it was trying to tear apart the continent, it was trying to tear it in half, right? So it created this very deep rift. In fact, if we were to take a snapshot of Lake Superior today and all the water in it, it would take almost 200, it's 191 years, so almost 200 years before all the water in that lake would be completely refreshed. Because it's so huge and so deep and so vast, it takes a very long time for the water to cycle through that. As compared to Lake Huron, if you were to take a snapshot of Lake Huron today, it would take about 22 years for us to refresh the water in all of Lake Huron. It's much quicker. But Lake Superior is so very different than the other Great Lakes that its retention time is much different. Let's see. I think I had a couple questions from some of our other students that were submitted today. One of them was, where did all the Michigan lakes come from? I hope we covered that in the program. And did water cause something? Did water cause the Grand Canyon? That was a great question. Absolutely. Because the sand and gravel that I have is very soft. So that part of the country, the sediments there were very soft. Well, the Colorado River, over the course of time, as it's meandering, it's making its way through, is cut deeper and deeper into the sediments and has caused the Grand Canyon. There are other canyons all throughout this country, not any as spectacular and as huge as the Grand Canyon, but rivers have caused canyons like this. White River in Arkansas, the Buffalo River in Arkansas, as they carved out those sediments in the southern part of the United States. So water moves land and it gives it this shape. But what I hope you'll capture from this is that the Great Lakes are really unique. And as you learned yesterday, we have, just a little bit of water, fresh water on this planet. 20% of it is in our Great Lakes. Tomorrow, we will be coming to you live to talk about the water beneath the surface, mostly about aquifers, aquifer investigation. On Friday, we're really going to focus on what you can do at home to help protect and conserve water. Because the water we have is the water that we had 100 million years ago. It's the water that we will have 100 million years from now. So we really need to protect it and take care of it. And of course, the Great Lakes is very important and special to every person that lives anywhere near them. And we hope that by the end of this week, you'll understand how important that really is. Thank you all so much for joining us today. I hope you learned a little bit, and we'll see you tomorrow.